So, in the last video, you learned about how to distinguish whether an exponential function was a growth function or a decay function. Today, we're going to look at functions based on word problems, specifically exponential functions based on word problems, and we're going to interpret what the function means to kind of help us understand better the different pieces of an exponential function. So the general format of an exponential function is f of x equals a times b to the x over n. If you don't have this written in your notes, this would be something good to write down. So for each of the pieces of this function, your a is going to be the starting value. If you were graphing a function, an exponential function, this would also be the y-intercept of the graph. So this is when your x is 0. But we can really think about it as we're interpreting our functions that the a is the starting value. B then is the base. That's the factor by which the exponential is getting bigger or smaller. It's what you're multiplying by every single time. The x is the time since the start of the exponential function. So we want to think about that as being from the start of wherever our exponential function was starting from. And the n is the interval of time. So you can think about that as if a disease doubles every 4 days, the interval of time is 4 days. So that's what would go in for our n. So we're going to use this a times b to the x over n when our base is a nice whole number, like something doubling or multiplying by 2, or tripling, multiplying by 3, or if it's a really easy fraction as it's decaying. So something like a half-life, if isotopes in chemistry have half-lives, and that in that case, your base would be 1/2. As the decay factor. We also have another type of function we can use, and it's really the same function, but the general format of it looks just a little bit different. And that's going to be if we have a percent growth or decay, which is going to happen a lot more often in the types of functions you might see, whether that's in pre-calculus next year, in AP statistics, or even in financial literacy. So the base changes slightly. Everything else stays exactly the same. So instead of having a base of b, we're now thinking of our base here as 1 plus or minus r. So that's the only thing that changes. The a is still a starting value. The t in this case is still the time, and the n is still the interval of time. We will use addition here if we have a growth percentage, and we will use subtraction if we have a decay percentage. And the key thing is that the r is the decimal of the percent. So if something is increasing by 15%, we're not going to use 15 here. We would use 0.15. So let's look at an example. Here's our situation. So you open a new savings account for college, and the amount of money in your savings account can be modeled by this equation, f of t equals 1,000 times 1.05 to the t power. We're going to interpret each piece of this function. So let's start with the 1,000. What does the 1,000 represent? So if I'm looking at this 1,000, it's taking the place of the a from my general format of the function, of the exponential function, and I know that a is the starting value. So the 1,000 represents that we started with $1,000 in our bank account. What does the 1.05 mean for this function and for this situation? Well, because the 1.05 is positive, I know that my savings account is going to be getting bigger. It's going to be growing. So this is an exponential growth function. But my bank account is not going to be growing by 105%. That would be ridiculous. Instead, we can take this 0.05 portion, since it's 1.05, and we can say that our account is increasing at a rate of 5%, since the 0.05 is the decimal of 0.05 is 5%. So that's what each of these pieces of the function means. Let's look at another one. The population of a town in Iowa can be modeled by the equation P of t equals 1,860,000 times 0.98 to the t divided by 4, where P of t represents the population and t represents years. So let's interpret the different pieces of this. What does the 1,860,000 represent? Well, looking at my function, the 1,860,000 takes the place of the A, so that's going to represent the starting population of the town being 1,860,000 people. Notice that when we talk about what it represents, we're really specific to the context of the problem. I cannot just say that the starting value is 1,860,000. That wouldn't tell anybody anything about the problem. I know that this is talking about the population of a town, so I know that the 1,860,000 represents the population of the town when it was starting. So then what does those 0.98 to the t over 4 mean? Well, I know that the t represents years. Since we have 0.98, 0.98 is less than 1, so I know that that's going to be decay. So I need to figure out by how much this is decaying. Well, 0.98 is going to show a 2% decrease, because 1 minus 0.98 is 0.02, and 0.02 is 2%. But this time I also have this 4, and the 4 is the interval of time. If you think back to or look back in your notes at the general form of these equations, the 4 takes place of the n, which is the interval of time. So what does this actually mean? This means that the town's population decreases by 2% every 4 years. So again, how did I figure out this 2% part? Well, if we're looking at the 0.98 here, I know that that's going to be my 1, since I already know that this is decay. 1 minus the r is going to equal 0.98. And if I solve this for r, so I'd subtract 1, so negative r equals negative 0.02. R would be positive 0.02. And 0.02 in decimal form, if you multiply by 100, is going to be 2%. So that's where I get my 2% decrease. Let's look at one more example. The spread of alpha-thyroiditis, which is a really rare disease that you can get. It's also known as the inflammation of the alpha-thyroid. The spread of this alpha-thyroiditis can be modeled by the equation A of t equals 3 times 2 to the t power, where A of t represents the number of people with alpha-thyroiditis, and t represents days. Now here's the nice thing about this disease. If you get it, it is not a deadly disease, so don't worry about it too much. But let's think about what each of the pieces of this represents. So what does the 3 mean in the context of the problem? Well, again, the 3 here is in place of the A. So again, if we think back, notice this time that I don't have a decimal. I have a 2. So we can think of this in terms of our f of x equals A times B to the x over n power. So the 3 is in place of the A. So that's going to tell me that the spread of alpha-etheritis started with 3 people. Well, then what does the 2 mean in context? Well, the 2 here is in place of the B, and we know the B is the base. So in context, that would tell me that every single day we're multiplying by 2. So the number of people with alpha-etheritis doubles every day. Now, why is it every day this time instead of every 4 days or every 6 days? Well, if we look at the exponent, there isn't an interval under the t. So that's just going to be an everyday situation. And I know that this is days instead of years because it tells me days in the question or in the problem itself. At this point, now that you've taken your notes, if you need to go back and review any of the video, this would be a good time to do that. Then move on to the practice in Canvas.